Hello, everybody. Welcome to the Business Performance Podcast. I'm Henry Schneider, and my guest today is Bill Curtis, who has been a longtime friend and colleague of mine. He goes way back with the quality movement, leading the effort in the early days with the Software Engineering Institute and Watts Humphrey to build the original capability maturity model. He was also instrumental with the people maturity model. He was one of the principals of one of the premier consulting companies, TerraQuest metrics, and lately he's been involved in developing international standards for measurement of size and quality of software. So please welcome Bill Curtis.
Glad to be here.
Okay, so Bill, would you please, just to get everybody familiar with you who don't know you, just describe what you do with CAST right now, your customers, and the types of services you're providing in your position.
Well, CAST is a technology company. We have a technology that analyzes large software systems, multi-language, multi-layer software systems, to find all the weaknesses in the code, both in the architecture and the code itself. So it analyzes security holes and things that'll crash the system, things that'll make it hard to maintain, and then provides that feedback and some metrics based on it, some metrics that would tie to the risk of the system back to the customer of the technology. So as part of that, when I was hired, the CEO said, look, right now all our measures are proprietary, and we know there's a limited market for proprietary things. We really need some international standards, and right now there just aren't any, and ISO doesn't provide those kinds of measures. So one thing I want you to do is go out and help create some international standards for measuring the actual structural quality of software from the source code. So we launched the Consortium for IT Software Quality back in 2010. I talked with Paul Nilsson, who, as you know, heads the SEI, and Richard Soley, who heads the Object Management Group, which is an IT standards organization that works internationally. And both of them said they had some people requesting that, especially OMG. A lot of the outsourcers had gone to them saying, look, we're starting to see these measures in our contracts as the equivalent of a service level agreement, but the problem is every customer has a different definition of what they mean by security or reliability or maintainability. We need standards. Mm-hmm. So we formed the Consortium for IT Software Quality as a special interest group in OMG, managed by the OMG, to build basically specifications for standards for measuring structural quality of software. Okay. And we measure it from the detection of weaknesses. For instance, in security would be, SQL injection, buffer overflows, cross-site scripting, and things of that nature that you can detect with static analysis, and then count those up, and then you can normalize that by dividing by lines of code or function points or whatever your favorite size measure is. Okay. And so we've produced 8 standards so far. One of them is now an ISO standard. We have a fast track from OMG to ISO, which is automated function points. So it's been, it's been a vigorous 10 years in that world. I'm also the American lead to the ISO 25000 series, which is the series that basically deals with measuring software quality, and we're revising the software quality model and trying to improve the measures. So it's we now have some standards in place, so you can actually refer to standards for measuring the quality and the size of software.
Okay, so how does the quality and size of software and the standards relate to business performance?
Well, pretty strongly. We've got some data. In fact, a number of data sets that show good correlations, strong correlations between some of these structural quality measures like reliability and whatnot, directly to incidents, to operational incidents in the software. We also have shown that reductions in the most critical structural quality weaknesses can cut maintenance costs substantially. Because it's just that you make the software simpler when you do that. So we do have a number of data sets now that are pretty convincing in terms of business performance to the extent, well, you look at the problems in the Wall Street Journal and New York Times now. Weekly, you're reading about major security breaches or major outages. These things are now what I call 9-digit glitches. They're 9 digits, bits or bytes, no dollars or euros. These things are stretching into the $100 million, 100 million euro range, and in some cases way exceeding that. And you don't know which weakness is going to provide one of those glitches. It's usually some interaction between several of the weaknesses that cause the big outages that are so hard to recover from.
Yeah.
So it does have a huge impact. Plus, the less maintainable the code, the less agile the business. You just can't make changes fast enough to the code if it's a kludgy mess. And that means your competitors can be more agile in the market than you can because they can get there faster with the changes to what's in their systems.
So, as you've gone through this, what have you seen as one of the two biggest myths or misconceptions about measurements and business performance over the years?
Well, I'll say one of the biggest misconceptions, some people say security is different from quality, that there's software security, that rubbish. The data absolutely blows that myth to shreds. The biggest what we would call quality problems also happen typically to be the biggest security problems. The things that would crash the system also open holes for hackers to exploit. So there's just lots of data now that show extremely high correlations between measures of the security of the software and measures of the quality of the software under the dimensions like reliability and maintainability. So that's certainly one myth that the data is pretty much shattered. That quality costs too much. Yeah, well, not when you have $100 million outage, like some of the airlines have had, or $100 million security breach like you saw at Target or Equifax or some of the others.
Sure.
You don't know which weakness is going to cause that. So the focus has got to be on certainly reducing the riskiest weaknesses within your most critical business transactions in the software.
Sure. So what's the biggest challenge now that people face? It seems like they don't react until bad things happen. But
yeah, it's getting executives to understand. I mean, they really don't understand software, and I'm not always sure that the senior executives in the software side, CIOs, VPs of engineering or whatnot, are doing a great job of educating them. I mean, they're not showing them what the level of risk is. The people that are now excited about some of these measures actually happen to be the corporate audit group.
Yes.
They're under a lot of pressure. By law, they have to provide a list of the major weaknesses to the business as part of the statements they make to the SEC and the public. And as you digitize more of the business, more of the risk is now in the software. And that goes for product companies as much as companies dealing with IT. I mean, you look at the impact of the software glitches on the 737 MAX 8.
Sure.
The stock prices dropped. And you look at the risk of security breaches and outages, things like that. They've got to be able to quantify that. And so these measures that we're providing actually provide a level of quantification based on the amount of weakness that can be detected in the software in these various areas like security and reliability. So that's a big issue. The business still barely understands that. They haven't quantified the impact of poor software on the business because they need to state, what does it cost if we have an hour downtime in our reservation system or in our website where our customers will buy our products. What's that cost? And the minute you start putting numbers on this, they start understanding the enormous risk as more of the business is digitized. And it's really developing that quantification that's going to be critical.
Yeah, no, even on a smaller scale. I know one time I was going on a trip out of the Austin airport here, and the whole airport system went down. They had to go back to old school paper to check people in. They couldn't do the scanning of your boarding pass. Yeah.
I mean, Delta estimated, I think, their last huge outage that ran over a couple of days, trying to get people back on airplanes was about $140 million.
Yeah.
So these things when they happen, are not cheap.
Sure. Yeah, no, and that's the whole thing, is trying to get, you quantify it, you finally get somebody's attention, but it's like otherwise they're in denial that they got a problem.
Well, and they're gamblers in some cases. Even if they can quantify it, they'll say, it's more important to focus on getting this new functionality out than fixing all this, what we'll call technical debt, all these weaknesses, and they ultimately pay a price. I mean, we need executive policies that are enforced not only by IT or engineering, but also by the business for spending some time reducing the critical technical debt, the stuff that can crash the system or allow a hacker to break in.
Okay, so could you please share a story of how you helped a company to overcome all these obstacles and succeed?
Well, I mean, I've obviously two different worlds I've been in. One was for a long time the process improvement world, and now I'm in more the product improvement world. You look at what happened in Six Sigma. Six Sigma was the rage in the business back in the 1990s, and there had to be a certain level of benefit in order to run a Six Sigma project. And eventually you ran out of runway. You just couldn't formulate a new project with enough benefit. And so they turned to what they call design for Six Sigma, which is our focus now needs to be on the product and how to design it so it's less likely to have weaknesses, so it's easier to manufacture, et cetera, et cetera. And that's what's slowly happening now in software. There still needs to be a focus on process. But we're realizing that the product itself is a major source of risk and weakness and cost. And so, that's now being added to focus on architecture, focus on reducing the severe weaknesses inside the software itself, especially those that are security related. The security emphasis now is extraordinary. So the biggest problem we have or one of the big problems is that and a lot of folks inside the business separate quality from development. In essence, we do development. Oh yeah, we got to have these guys go measure, whatever they're measuring, process or quality or whatever. That measurement is somehow separate from development activities, which is absolute rubbish. In engineering, you don't do engineering without measurements. It just doesn't make any sense. And we need to get that sense in software that if you're going to do software engineering, measurement is a part of what you do as you develop the product. I want to continuously measure whether we're building the quality in or whether we're going to kill ourselves in testing, trying to find all the screw-ups that we made, trying to build this thing too fast. And so that's a huge issue, is getting people to understand measurement is the essence of engineering. It's integral to the engineering and development process. So that's one. Getting executives to use the measures is another challenge. Getting them to integrate that into their process of how they manage, of what they expect to see, how they're going to use that in their quarterly reviews, how it's going to be used, below them in weekly reviews and that sort of thing, how it's going to be used in the middle of sprints to determine, are we releasing something we shouldn't really release because there's things fixed that are high risk. So getting this integrated into both the management and engineering process is fairly critical. Finally, an interesting problem we find with an awful lot of companies, if you're going to measure the product, the entire IT product, the entire application system, you've got to be able to find all your source code. You can't believe how many people don't know where their source code is. They got big chunks of it, but then you will say, well, hold it. This is, calling that piece over there. Where is it? Oh, I don't know. Somebody go find it.
It's a black box.
Yeah. It's just interesting watching them try to locate and integrate all of their source code again.
Wow. So you mentioned about cybersecurity. So I remember several years ago hearing you speak and talk about a credit card breach and what that did for you. So can you relate that to?
Oh yeah, wow, that was one Saturday. Was it Saturday or Friday? Anyway, one morning, apparently I enrolled for this was like 2010 or so, 2011, something like that. Apparently, one morning I enrolled for the spring semester at Baruch College in the center of Manhattan. About 30 minutes to an hour later, I had 2 LASIK procedures performed on my eyes in Orlando, Florida. 30 minutes to an hour after that, I bought $4,000 worth of art in Kansas City. And an hour or so after that, I bought $10,000 worth of art in Sydney, Australia. Obviously, I don't have supersonic flight powers. So Card, realizing I wasn't supersonic, canceled my credit card. Obviously their neural nets had detected this just doesn't make sense. Even with the way Curtis travels, it makes no sense. So they canceled it, and apparently me and the 140 million of my closest friends had our credit cards breached. That was a famous Heartland breach, and so they did a great job. Within an hour, they had texted me, called me, and emailed me, saying, we've detected that your card's gone. We've canceled it. We'll arrange for you to get another number. So the good news is their systems work. They use a lot of neural nets and other kinds of detection systems. It worked. I feel sorry for the art dealers, because they've probably lost the art. I mean, they're not going to recover that, or the LASIK procedures aren't going to be reimbursed. But here's the crazy thing: how can some kid enroll in Baruch College on my credit card and figure he's not going to get caught the first day of class when the police walk in?
That's right.
Even bigger question: why would Baruch College enroll somebody that dumb?
Yeah, and using a credit card too.
Yeah. I mean, the kids did. So at any rate, that just was that was. And now Henry, here's the worst part of it. The breach had been going on for a long time. I mean, these guys are smart enough not to take 140 million records out in one pull. They'll do it over a long period of time. They'll take a few thousand this day, 10,000 that. So it doesn't look strange if you're monitoring what's going on in the database. They eventually got caught, and it ends up that they had broken in through some weaknesses called SQL injection. In essence, the software didn't vet what was being input in the user interface, and the guy input basically some SQL commands. They got down to the database and says, "Please send me your credit cards." I mean, probably more complicated than that. But the hell of it is, we had known about SQL injection for over a decade when that happened, way over a decade. Why hadn't they removed those weaknesses from the software? Everybody knows about SQL injection. Everybody knows that's a well-known weakness. This is the first one hackers hunt for, yet we still find those kinds of weaknesses in the software itself. So a lot of organizations are doing a very poor job of going in and really inspecting their business critical applications or customer facing applications for known weaknesses that are easy for hackers to exploit.
Yeah, it's amazing. And when you start stacking things together, you add additional vulnerabilities that nobody even understands.
Yeah, once you get multiple languages on multiple layers, calling other systems, it gets pretty scary.
Okay.
It's going to be especially scary when we get into the Internet of Things, and they can break into one system and get over to your pacemaker.
Right. Yeah. I mean, that is really scary. Or your refrigerator and then take your house down.
Yeah.
So thinking about from cradle to when you were born to where you are today, what defining moment in your life inspired you to be an advocate for software quality?
It's a long story. I went to college and as a math major, got fired up about behavioral science. So I really went into building mathematical models in the social and behavioral sciences as an undergraduate. Went to graduate school and ended up spending more time studying statistics and experimental design and measurement theory and these things, although my PhD is really in organizational science, organizational psychology. But I spent 2/3 of my coursework on the computer, doing data analysis and whatnot. I learned Fortran without knowing I'd actually learned Fortran. Because what I didn't know is the user interface language for SPSS was Fortran 4. And I got to GE Space Division. They hand me a download program from a satellite. And I said, "Oh, you guys use SPSS." And they said, "What are you talking about? That's Fortran." So, but at any rate, so I got my first job at the University of Washington, teaching statistics in the Department of Psych and doing organizational research. And because I lived in the computer center analyzing a lot of data, the chairman of the department asked me to be on a dissertation committee for a fellow that was doing work on the psychology of programming. And the fellow's name was Tom Love. Some of you may recognize that name as one of the two guys that created Objective-C. So which is, was Apple's big language when Steve Jobs came back and took them over. But at any rate, Tom hired me into GE Space Division to come help do statistics. He was studying whether you could predict programmer performance with Halstead and McCabe's metrics, whether things like structured programming actually improve programmer performance and things like that. So it was behavioral research, but in software engineering. And the first time Tom offered me the job, I turned it down because it was a soft money job, and I was tired of soft money. I wanted a hard money job, so I went to Weyerhaeuser as their organizational psychologist, and pretty soon they fired my boss and killed my department. So that ended up being pretty soft money. So Tom happened to just call me back one day, and so I did, fine, let's go, give me an airplane ticket. So I went to GE Space Division and started doing this really behavioral research on software engineering, and just fell in love with it because it took me back to my, my math background and my statistics background and living on computers. And holy cow, I actually knew Fortran 4 and didn't know it. But at any rate, that really was the launching event of getting me into software and studying this and measuring software and seeing what we could predict with those measures. And then from there, I was hired into ITT, the back then telecom company, to build a worldwide database on productivity and quality of their far-flung software operations. Because, all of telecom back in about 1980 was switching from relays to digital systems. And most of these companies really didn't know much about software, and they were scared of it. So we went in to try to measure the productivity, measure the quality, help them figure out what are better practices when you're trying to measure this intellectual artifact that has no physical instantiation. So I was there for 3 years. ITT ultimately lost out. It was clear to several of us that were collecting the data, they weren't going to make it. At about the same time, MCC was starting down in Austin, the big fifth generation research consortium. And I'd been doing some user interface work for a while, especially up at ITT. And so I got hired to build the user interface lab and try to integrate AI techniques with good user interface practice. And then Les Bellotti came in to run the software technology program, and he brought me over. And this was another critical thing. He offered me, said, which program do you want to run? And I thought everybody thought I'd take the interface program, to interfaces to case tools, basically. But I saw the design process as being by far the most interesting. So I said, let me run that one. And we started really studying what do people do when they're building large systems. We videotape designers doing design, trying to design a system. We videotape teams going through a design process. We went out and interviewed large project teams on really, really huge, humongous projects out in corporations, and really started blowing the shreds out of the existing theories of how people design software. I mean, the top-down stuff was cute, but nobody did it that way. In fact, David Parnas had written a wonderful article called "Top-Down Design and Why to Fake It." And the notion was, when you're finished, you want the documentation to look top down because it's easier to understand and see what's in the system. But that's not the way you're going to do it. That's not the way you're going to actually build a system. And we had videotapes of guys just really going all up and down the levels. They have a design idea, but they have no idea if it'll work. So they drill all the way down to almost the code level to say, would this work out if I actually did it this way? And then they'll come back up to the top. So it was this constant moving up and down the various levels of design to see what was feasible and what would work. And then we started building tools to try to capture that way of working that would allow people easily to move across layers of design and communicate effectively across the team. Watts Humphrey happened to see what we were doing. And so this was a seminal moment. He asked me to be on his advisory board as he was trying to formulate the process maturity framework. So I'd go up to Pittsburgh 3 times a year with a bunch of other folks that he had invited. And we'd sit there for several days with Watts and just argue like the dickens about this model and what it was, and say, Watts, can you just give us a concrete concept of what you're thinking about here? And he would struggle, and we'd struggle with him and work on it. But Watts could see that I actually understood what he was trying to get at, and started believing that there really was some sense in the constructs he'd come up with and the way to organize the model. So when he decided to retire and step back, he asked if I would come take his job, and so that was, that whole thing was a seminal to me going to the SEI, taking Watts's position as he stepped back. At that point, all we had was the book and the questionnaire. And there really wasn't a defined assessment process. It was really people would go out with Watts and go around the halls with him and sit in the room while he conducted these interviews. But we really had to formalize all that. So I launched the project to formalize the model, formalize it into the CMM, formalize the assessment process. And so over a couple of years, we were able to accomplish that. And so there was a lot going on in the process program. I had a measurement group reporting to me, and Anita Carlton was running that. And she did a great job of really producing some very good documents defining measures that for DOD that they could use for size, quality, effort, and schedule. And so there was just a lot of things we produced. The problem was I couldn't move my family up to Pittsburgh for a whole host of reasons. We couldn't even get the mortgage back on the house because that was back when there was an oil crisis, there was a savings and loan crisis, and people were basically walking away from their houses if they had to move. So my wife and kids stayed in Austin, and then I promised I'll be back in 2 years. So they would. The SEI was really nice. They would send me for conjugal visits back to Austin every to kind of preserve the marriage. And so I came home after 2 years. And a couple of colleagues called me, Don Oxley and Joy Stotts, who were in the process of forming a company, and asked if I would like to join in with them. And I had started a consulting operation. I had some contracts, and so we joined together and formed TerraQuest Metrics, which fortunately you later joined as one of our star lead appraisers.
Oh, thank you.
And so TerraQuest grew from the three of us to ultimately we had about 40 people and somewhere like 10 affiliates. Out doing process improvement work all over the globe. So it was exciting, and eventually Borland came and offered us, made us an offer we couldn't refuse, and we sold it to Borland. And then Borland probably went down the tubes within 2 years. So, we all left and went on our merry way. And at that point, I spent a little time at McAfee helping them get some processes in place to deal with a consent decree they had to comply with. And then CAST found me. They wanted to form an advisory board on software quality and measurement, and I was recommended to them, and we talked, and they realized we ought to bring this guy on board. So I looked at it and said, this takes me back to my software measurement days, and this fits right in my alley. I love the opportunity to go, and especially since they want to build international standards, this is a real chance to have another big impact on the world.
Yeah.
So I joined, and we formed CISC. I've done a lot of internal work in CAST. Every 2 years, we publish a report called the Crash Report. CAST research on application software health, and basically we look at the data we've collected globally on the structural quality of applications. And I think this year we'll have over 2,500 applications from North America, Europe, and Asia, and we analyze those and say, here's where the world stands on security and reliability and maintainability and what have you. And here's what we see are the major factors. And I'll tell you two of the things we've seen. Number one, we've seen that the hybrid development methods are more effective in terms of structural quality than either pure agile or waterfall. It's that hybrid that says we're going to do sort of the waterfall style up front to make sure. Now, these are large applications. They're not small. They're not small things. That we get the architecture right, because you really can't refactor an architecture. You can kill it, but it's hard as hell to refactor it. So you start to make. You don't have to have the whole thing defined, but enough that you're going in the right direction and it'll hang together. And then you start the rapid sprints where you're rapidly building and testing. So you're making sure the quality. If you do it right, you make sure the quality doesn't get out of hand because you're evaluating that at the end of each sprint. So and hopefully they've protected some portion of their stories in the next sprint for retiring some of the technical debt they've detected that's dangerous.
Yeah.
So we find that method, that hybrid method, works best. Second thing, and the CMM world will like this, we found that, yeah, there really is a correlation between CMM levels and structural quality. And the difference is really the difference between level 1 and levels 2 and 3.
Yeah.
That level 1 is significantly lower in structural quality than levels 2 and 3. And I don't think anybody in the lead appraiser world is going to be surprised, because they see it every assessment,
Right.
where a level 1 is just out of control, and they just can't keep up with the quality problems. And whereas at level 2, one of the first things you do is you get control of commitments and get control of the baselines. And so you start putting in place the processes and the infrastructure to control quality. So you don't throw people into chaos mode, and you do some control over the product itself. We didn't see a big jump in structural quality as you go to level 3. The big jump is going to level 2. Level 3 is more about getting an economy of scale by having a standardized process across the organization. We didn't have enough data on level 4 and 5 to show what happens when you go to those levels.
Okay.
I know I've seen some data that says it's pretty dramatic, but we didn't have data of enough level 4 and level 5s to evaluate that in what we were doing. But both CMML level and development method did have impacts.
Okay. So can you share an experience you had growing up that still influences how you approach business and work today?
Wow, playing quarterback. I mean, all my life I wanted to be a quarterback. My senior year, I got to be one. And at that point, you have tremendous responsibility. You've got to organize. Everybody's looking to you to make the decision, call the play, make it work. And that's everybody think, well, you're just a jock. Yeah, but when you play that position, you're also a manager. You're the on-field manager of the team. And that really wanting to do the things to get prepared for that, the personal changes I had to make. I grew up without a father. I came up in a divorced home, and that puts a lot of challenges on. And I had to overcome some of the problems that left in order to be able to have the respect of the team and to be able to move into a position like that. So that had a lot of impact. I always was good at math, and there's no question that helps, because then you think logically and you appreciate the elegance of a beautifully designed piece of logic, whether it's a proof or a program. And so those two things, I think, had a lot of impact on the fact I do appreciate really well-designed, well-developed software, and appreciate a disciplined process and good management to help create an environment where you can do that.
Okay. So what do you see as your next challenge, or are you kind of just going to ride this out?
Well, I think trying to help drive the maturity concept beyond software. Watts saw this as a software process thing, but with my background in organizational science, the minute I got involved with that model, I said, man, this is more than that. This is probably the only unique model of organizational development that had been developed within 25 years of when Watts had come up with. Everybody else says, you start with this organizational stuff. And Watts said, no, that doesn't work. We've seen that not work for 50 years. You've got to stabilize local work first, and that's what level 2 is. That was a unique insight. I mean, he was basing it off Phil Crosby's model, but Phil started, Phil's was a continuous model. I don't see that working because it's not organizational. It focuses on individual processes and not the organizational transformation. And the power of the maturity model, as I saw it, was that organizational transformation. And Watts saw pretty much the same thing. But I realized I can take this concept and apply it to a lot of other dimensions. And as we were getting the CMM out, I was, as director of the process program, I was getting calls from lots of people saying, look, this is great. It works. It helps us get our management and our configuration control and all these other things, in order. But we got all these people problems, and you didn't say a word about that. We need help. We've got retention problems. We've got compensation problems, and they went on the list. And so I launched the People CMM, and and it was funny. People say, how can a software institute come up with an HR model? Well, I didn't tell people that my background was actually organizational psychology, which is, that's their field, is all of these things. So, but I basically built the people CMA, integrating the full suite of human resource, human capital management practices into the maturity concept. And we had to get it right, and Watts's dictum was, you've got to stabilize local management first. And so we got the abstractions right to say the first thing we've got to do is help people that supervise local work be able to manage the workforce issues in stabilizing that local work, staffing, managing performance, dealing with training and development needs, and providing the resources people need and all that. So we got that abstraction right, and built that. And in India, it got heavily used across most of the major outsourcers. Some use in the U.S., some use in Europe. Ericsson certainly adopted it, but not as much as we had hoped. But, in India used it, a lot of them got up to level 4, level 5. And now I think what they're saying is that we're not really worried about compliance to the model, but we do go pick the best practices, because there's a lot of things in there we realize will improve our ability to retain people and build skills and that sort of thing. So that made me happy. Now that the next objective would be to get this out into areas that desperately need it, like healthcare, education, other areas like that. We do have a business process maturity model that is a standard with the object management group, and it's a true maturity model. I'm not fully happy with it, because when we built it, we had generic practices in it. I've been against generic practices since CMMI got formed, because I think it just adds bureaucracy and excess that it bloats the model, badly bloats the model. And so we'll probably have a revision of it at some point in the future. We may build a meta model that you could then apply to any domain if you get the abstractions right to take into healthcare, education. But the first thing you got to realize is what constitutes local work. It's not the school, it's the classroom. It's not the hospital, it's the ward. And so when you get those abstractions right, you can build a maturity model that really has tremendous impact on changing an organization's performance.
Sure. So what about startups and entrepreneurs? How can they benefit from this? Because all they're looking at is good ideas and trying to come to market as fast as possible with a minimal viable product.
Yep. Well, reading that book, the Lean Startup is a good place to start. And I read it and I was amazed at how much he talked about process.
Yeah.
It's not like just y'all get out there, run free, and just hack away and build as fast as you can. He actually talked about a level of this. If you put a crummy product in the market, the market's going to try it and drop it. If you build a good product that people like, that they see as an advantage, then they'll come back for more. So now here, the biggest problem with startups is that the founder doesn't survive the next big jump in size and whatnot. Most founders are basically run out by the venture capitalists or funders or whoever, because they simply can't manage the company at the next level of growth. I think a role model here you ought to study is Michael Dell. Michael started out of the back of his station wagon and now runs one of the largest computer companies in the world. And Michael was smart. Michael knew he didn't know how to manage at the next level, so he got him a board of directors that could guide him and tell him what to do and help him find the people he needed to manage at the next level up. And so my advice to young entrepreneurs is, number one, discipline is important. Quality is important for what you put out so that people will stay with you. But also be aware you may not have had experience. If you grow fast at the next level up of management, find people like Michael Dell did who can guide you in what you need to do and what kind of people you need to bring in to manage the growth.
Okay, great. Well, thank you so much, Bill. Just one last question. How can anybody get in contact with you if they want to learn more about what you're doing with CAST, or just, ask questions like
process improvement, process improvement or measurement? You can get a hold of me. Email Curtis, Curtis, at acm.org. I'll have that email address. It'll be active until a year after I'm dead, because it'll take a year for ACM to realize I haven't paid my dues and shut down the account. You can get me at my telephone, 817-228-2994. But email me first, because if I'm overseas, you'll wake me in the middle of the night, and I won't be very happy. But and you can snail mail me at P.O. Box 126079, Fort Worth, Texas 76126-0079. But I encourage you, Curtis at acm.org. Happy to get the email, and happy to respond and help you in any way I can.
Okay. Well, Bill, thanks so much for your time today. This has been wonderful talking to you. I've learned more about you today than I think I've learned over the past few years.
We were too busy doing assessments back then.
Yeah. Okay, well, thanks so much for your time.
My pleasure. Bye-bye, Henry.
Bye-bye.